Okay, today we're simplifying square roots by adding and subtracting. Alright, if you simplify square roots by adding or subtracting, right, the factors of the square roots, make sure one is a perfect square root. So you want to make sure that if you have one that's a perfect square root, that you figure that out first. Okay? Like, say I have this, and I'm using this as an example. If I have 36 plus 9, Tanaya, if I had 36 plus 9, that's easy because those are perfect square roots, right? You can add those quite easily because what's 36?
6.
Or what's the square root of 36? 6, right? What's the square root of 9?
3.
3. So the answer would just be
6 plus 3 equals
6.
9.
Yeah. So those are easy, okay? What we're going to get into is if they're hard, if they're not perfect square roots. Okay? So you're going to, if they're not perfect square roots, you're going to pull out the radical sign. Okay? If the radicands match, underline that, if they match, then you can add or subtract the coefficients. The coefficients are these big numbers that are in front. You can circle them if you want to. So everybody understand what a coefficient is? What's the coefficient? The number that's in front. Good. Or on the outside. Good. Okay, so let's look at these. The first thing you're going to look at when you look at your example, you're going to say, hey, is the square root of 54, is that a perfect square root? Yes or no? No. Is the square root of 24 a perfect square root?
Yes.
Yes or no?
Yes.
No. Y'all need to practice.
No, it's 25, not 25.
It's not, it's 25, not 24. So when this happens, you have to factor it. So put factor tree. So we're going to make a factor tree. While we're making the factor tree, we are going to ignore the coefficient. I want y'all to circle the coefficient so that you don't forget about it. Okay, but I want you to ignore it for right now. Everybody know how to make a factor tree? Yes, you should know how to make a factor tree. Okay, so I made your big example larger because I want you guys to be able to see it clear. I have already told you to circle what?
The coefficient.
The coefficient so that you don't forget about it, right?
Yes. Yep.
Okay, but I'm going to leave it alone to the very end. My first step, what am I going to do? I told you guys that you're going to factor. You're going to factor the radical.
So what?
Yes, you're going to factor the radical. So I'm going to factor the radical, and then the step 2 is I'm going to circle the coefficient. All right, factor trees. Look at me factor. Watch. What times what equals 54?
9 times 6. No, 8 times 6. I think.
9 times 6.
You're not supposed to have a calculator. No, 9.
That's 9 times 6. No, it's not 6.
Yeah, it's 9 times 6.
9 times 6. Watch this. 9 times 6. Is that right? Yeah? Are any of those perfect square roots? Is 9 a perfect square root?
Yes.
Is 6 a perfect square root?
No.
No. Okay? So I'm going to show you this 2 different ways. I'm going to show you it the dating way. Okay? The dating way. Okay? Is this factored? Do I have all prime numbers?
No.
No.
Is it
Because I can break down 9 into what?
3?
3 and 3. Are they prime now?
Yes.
Circle them. Can I break down 6, Quasia?
Yes. 2 and 3.
Yes. To what?
2 and 3.
2 and 3. Good. So now I have everything broken down and I circled everything, right? Now we're going to see who's going to go on a date. You're only going to date people that you're compatible with, okay? The twos don't want. So we're going to talk about going on dates, okay? These dates, they only like each other if they're alike. They're really stingy. So they only like other 3s. So like if my 3 has another 3, they can go on a date. They can be together, okay? But my 2 and 3, they can't go on dates. They don't like each other because they're like, you're a 2 and I'm a 3 and no ma'am, okay? Any 3, any pair, which I have a pair of what?
3s.
I have a pair of 3s. So they can, I got to have a house, right? There's my little square root radical house, okay? They can go outside on a date. And I'm only going to write 1 3 because they're taking the same car. They're taking the same car. They're both 3s are the same. They're taking the same car. All I got to do is write a 3. Okay. All right. What else did I have above there that I circled that I forgot about?
Your
5.
your
And I'm eventually going to have to multiply those 2. Okay? What do I have left that's going to, like, they're going to stay in the house because they don't have no date? What? A 2 and a what?
3.
A 2 and a date. 2 and a date. 2 on a date and 3 on a date is not going to happen. So 2 and 3 right here, they have no dates. They have to stay in the house.
Miss Bowling, but what about -2 and 2?
Why'd you put a time sign?
Because anything that's left together that's not pulled together is multiplied.
But this one,
So when you simplify it, you're going to simplify it to be 15 square roots of what?
15.
Because 2 times 3 is what? 6.
That's the answer?
Okay? My girl just asked me if I was done. But no, because I have a subtraction sign that I have to bring all the way down. This looks long and tedious, but it really isn't the more problems you do. Is the square root of 24 a perfect square?
No.
No. So then you got to factor tree it. So what 2 numbers can you multiply to get to 24?
1 and 6.
6 and 4. You could have used 3 times 8. It doesn't matter. You can use either factor.
3 times 8.
So what can I break down 6 to?
You can break down 6 to 2 and 3.
2 and 3. Are they prime?
No. Yes. Yeah.
They're prime, so I circle them. What about 4?
2 and 1.
2 and 2, so I circle them. Do y'all see any dates?
I see 1. I see 1. 2 and 2.
2 and 2 is a date, right?
They want to go together.
Can they go together?
Yes.
Yeah, they getting out the house. They're going on a date. And then who stays inside? Who's lonely and stays inside? 2 and 3.
The same thing again.
Kind of like the same thing again. So 2 and 3. They got to stay in the house like Jerry with no date.
Miss Bowler, let's talk about how you met for like 6 months.
True. That was 8 months, man. All right. So what am I forgetting that is up there still?
Your coefficient.
The other 2. What girl?
Coefficient.
Coefficient. Good job. And what do I do with that?
You bring it down.
You bring it.
I bring it down, and I got 4 square roots of what?
6.
6. Now look at this. Does this match where do my radicals match where I can add and subtract them now?
So how do you know what's going on? So what is we supposed to track it?
Yes, if they match. So look, I'm going to write it smaller now. because they match, so we're good, okay? I'm going to take all of this and I'm going to move it up. So I have a square root of 15. Oh, my bad. Square root of 6. I got the square root of 15 minus 4 square roots of 6. Are they the same in the house? Is the radicand the same? If the radicand is the same, that's good for you. That's like having like terms. So now all I have to do is what? Subtract. 15 minus 4 is 11. And my answer is 11 square roots of 6. Because you keep the 6. And I know in this video, I know y'all be hearing all these people yelling out wrong answers, and I know y'all know who they are. So don't be making fun of them in the hallway. Thank you. So this is the answer, okay? That is your answer. Let's try to do the next one. Okay, let's do the next one together. The square root of 32 plus 2 square roots of 50.
No, it's a.
Okay, here's our second example. What's our first step?
Circle the
Find the
coefficient.
factor thingy.
Do the factor trees and circle the coefficient. What's the coefficient on the first one?
2.
The first one.
Zero.
And it's zero.
Nothing.
That's zero.
That's nothing.
Yes. Okay. All right, how do you factor 32?
Something that you can multiply.
What can you multiply to get to 32?
1.
6 and 4. 6 and 4.
6 and 4.
Okay, we had to have a little mini chat about some multiplication going on because somebody, yeah, okay. Anyway, moving on. If you don't know how to multiply, you better get yourself a multiplication
Michaela.
chart. All right,
What's
so
your name?
4 and 8. Factor tree it.
2,
2, 2, good job, Tanaya. Then what?
And 2, 4.
4.
4 and 2.
4, 6.
And then 2 and 2. Circle all your prime numbers. Am I circling 4?
No.
No, because it's not.
No,
Oh, you
it's
circling all
not
the
prime.
twos.
Good. What I am going to do is I am going to underline all the dates. How many people can go on a date
I know why
together?
you're circling 2.
2. I got 2 couples going on a date, right?
You
So,
only gone on a date.
They are not all going in the same car. So every single one is going on a separate car. So one pair of 2 and then another pair of 2. Do you guys see where these come from?
Yes.
Okay. What's left that don't have no date? 4 is not circled.
2.
2 had no date.
Is it the same thing? though?
This is the same thing. So now I have to go and I have to multiply what?
Times 4.
So I have 4 square roots of 2, right?
Hold on. What?
Because it's on the, why do we put it on the outside?
Because that's the
Because that's, the dates go on the outside. The pairs go on the outside.
I thought
Okay, the next one. What 2 numbers make 50?
5 and 10.
5 and 10. Is 5 prime?
No. Yes.
Yes.
Yes, circle that bad boy. All right, 10. 2 and 5. Do I have any dates?
Yes, 5 and 5.
Yeah, 5 and 5. They can go. They can go out, right?
Yes, sir.
So they are going to go out. And what do I have to not forget about?
Your 2 that goes on the outside.
Okay, 2 goes on the outside. Who has no date?
5, 10.
10's not circled. It doesn't matter.
2.
2 has no date. Sad little old 2 has no date. So 2 times 5 is 10, right?
Yes.
Square root of 2. And now, are the radicands the same?
Yes. You don't have to change
Yes. What do I add?
it. 4 and 10.
4 and 10.
Which is
4 and
14.
10. So what's my answer?
14 square root of 2.
Yeah.
Yeah. Y'all are the bomb.com.
Dang, I feel smart today.
Yeah, you smart today.